me record. Here we go. Arc QR is 72 degrees. So the arc is 72 degrees, and I want to know how much does the angle measure. So who can tell me? Is it also 72 or is it 36? So, okay, so we can eliminate A and B, and it turns out, good, it turns out that it is D because, wait, no, not D, sorry, C. Tricked y'all. C, because what happens is that the central angle would be 72 degrees. So that's 72 degrees. Okay, but the, what's this called? Not central angle, but what's this one called? Inscribed angle. I'm talking about the angle. The inscribed angle would be half of the central angle. So don't get fooled. It's not really hard. It's not hard. You just gotta be careful not to get tripped up. Any questions on this? Anyone? Okay, cool. So we're gonna spend about 10 to 15 minutes just doing a few more problems about this that we didn't get to yesterday. And then we'll do a new topic, which is pretty easy in my opinion, and it'll be pretty quick. Hopefully we'll finish early, and then you guys will have some time to work independently on Khan Academy. No, circles are not done. There's still more to learn. The two things we've learned today are pretty easy. I'm giving you more Khan Academy, Perla. So, okay, here we go. SOT is 68 degrees. What's the measure of SRT? 34. Easy. Easy, easy. What's the measure of ST? ST. ST would be 68. Good. What's the measure of arc SRT? SRT. $104. It's not 104. Check out the math. Wait, maybe it is 104. No, it's not 104. No. Not 112.
So I came in late because of my computer. I was having problems with my computer. So what did I miss?
Nothing, not really so far. We just did this question and the bell ringer. So we're just going over what we learned yesterday.
What I think I'm seeing is that this angle SOT is basically just 2 times the angle SRT.
Yes, exactly. And so right now I'm asking, my question right now is, what is the measure of arc SRT?
Arc? I forgot what arc was.
So Janelle's is saying 292. I've seen 180. I've seen 112, 102. I've seen a lot of different answers. So let's see if we can come together to figure out which of those might be right. So I guess let's quickly, what is SRT? Arc SRT. If this is arc ST, that's my minor arc. What's arc SRT? The major arc. So SRT is all of this. So if you think about it this way, let's see if we can come up with the right answer this time. Who's screeching, the children or the teachers? Oh God.
That is the one. That is one of the life answers that will. That is one of the life questions that will never be answered.
Okay, well, try your best to focus, try your best to pay attention. I know it's tough, but hopefully she stops soon. But now let's think about it. If the minor arc was 68 degrees, what would be the major arc? Jalen agrees that it's 292. Perla agrees. Good. So what did you guys do to get 292? Good. Subtract it from 360. Because all circles add up to 360, right? So for that reason, that's what we get. Any questions on that? Makes more sense. Good. Good, good, good. Any other questions? Awesome. Cool. All right, let's do another one. Okay. So this is a kind of a different thing compared to what we've done before, but I want you guys to really try and visualize it as best as we can. So if ACB, so angle C is 55 degrees, the question is, what would be the measure of D?
So I think we should try to reflect the center and then see what kind of dilation that is, so we can find out the angle.
Okay, so a dilation or a reflection might help, like you're thinking like this.
Yes, so we could figure out how the shapes resemble each other.
Okay, so that's a really good way of thinking about it, Daniel, but there's actually an easier way. Kind of easier. So let's see, Perla thinks it's the same. Why would it be the same?
Because they may be different shapes. They may have different sides, but they're both the same triangles.
Okay, so someone next door is hammering something. I don't know what's going on. Okay, so remember that we have an inscribed angle. This is an inscribed angle, and it's touching A and B, right? And the thing with inscribed angles is that no matter where they are, as long as they're still touching A and B, let me see if I can make this work. Oh no, because I would have to flip it. But as long as they're still touching A and B, they're going to be the same exact measurement. It's still going to be 55 degrees, no matter where you go, no matter where you go on this circle. As long as it's touching A and B, it's going to be 55 degrees. So that's why ADB is it also 55 degrees. And you could go anywhere. Like if I have a circle, and actually let me make this a little bit more obvious, because I know that this is a little bit hard to like fully understand sometimes. Okay, so there's my inscribed angle. As long as the inscribed angle is touching A and touching B, even if it's over here, that's still 55 degrees. If it's over here, it's still 55 degrees. If it's anywhere on the circle, no matter what, it's still going to be 55 degrees. Does anyone have any questions on that?
No.
Okay, so that's just something that I want to get very, very clear about these types of triangles. Okay, questions on that?
Nope.
Yeah, it's just in different places. Actually, and this is something that I want to show everybody because I know, Daniel, you were here yesterday, so I'd quickly, so you missed something that might be even more useful. So give me 1 second, I'm going to share it again because this really helps to visualize it. Let me see if I can find it. It was from yesterday's class.
Okay.
Okay, just give me like 5 more seconds. It's loading. Okay, so go ahead and everybody just take another minute or so, and when you see the link in the chat, I want you to click on it and just spend a couple minutes like looking at it again. Even though I know most of you did it yesterday, it's still useful. It's a useful tool. Okay, oh, wrong link, hold on. That's the Zoom link. Okay, there we go. All right, go ahead and click on the GeoGebra link. And this is especially for Daniel. I just want you to look at it, Daniel, because it's really useful. Move all the little dots around so that you can kind of see the relationships. All right, Perla, we get it.
I don't understand what this has to do with last class. Um, what is this?
So this is exactly like what we're talking about right now. So look at the inscribed angle, move it around. Does it ever change as you move it around?
No, the inscribed angle never changes.
Okay, now see where it says the little green slider? Slide it and tell me what happens.
So the blue thing inside of the inscribed angle goes to the central angle. Two of the inscribed angles make the central angle.
Exactly. So those are the two most important things that we learned yesterday. So that's exactly what I wanted to do to show you is that the inscribed angle does not change at all, no matter where it is, as long as it's touching the two red dots, it stays the same. And then the central angle is twice of the inscribed angle. Make sense?
Yes.
Cool. All right. So now everybody go ahead and head back to the Zoom so that we can do a few more problems of review. So on that note, now that we kind of talked about it, go ahead and take a look at this problem and let's go ahead and answer it in the poll. Okay, I have 2 answers so far. Okay, let's go. Go ahead, and you should have had plenty of time now to read everything, so read it carefully, answer it in the poll. Okay, 5, 4, 3, 2, and 1. All right. I'm not going to share the results because y'all will be embarrassed. Just kidding, because I want to go over it. So, what did we just talk about? What did I literally just talk about over here? What is the same in this one? The inscribed angles. So D and C are congruent. What else would be congruent, by the way? A and B would also be congruent because both of them are inscribed angles that meet up at the same place. Middle one is 90. We don't know that. We can't say that for sure because we don't know the measurement of A or B. Now, do they pass through the center? Do they need to pass through the center? Nope. Okay, so now let's look at this. Here I have pretty much the same situation. Pretty much the same situation. What's wrong with this picture? Why is M wrong? Ah, but here's the thing, Perla. Is M the center? So that doesn't really matter because what matters is that this needs to be 118 degrees. But there's nothing, absolutely nothing that M has to do with that arc. There's something else that is way more wrong with this picture. What's wrong with the inscribed angles? These two angles must be equal to each other. Must. If they're both passing, look at what they're both passing through G and J. So if they are both passing through G and J, they should be exactly the same, but they're not. That is what's wrong with this picture. Everything else is totally fine. But the fact that these two are not equal is a problem. So the answer was answer choice C. Okay, JH does not need to pass through the center. There's no rule that tells me. And in fact, if it did, if it passed through the center, then the angle measurement would not need to be equal anymore. So it doesn't need to pass through the center. There's no rule that says that. GH should be equal to JK. GH should be equal to JK. No, there's no rule about that either. But there is well, no, not in this example, never mind. And then last, the measure of HMK should be equal to half the measure of HK. So we already went over that those have no relationship to each other because M is floating in the middle. It's not the center. It's not anything else. Any questions on this one? Okay. I have one more. Can I have a volunteer read this one for me, please? Who can read?
Line segment CK is the diameter of circle O. If MJC equals 19x and MJK, and the measurement of JK equals 9x plus 2 minus 6, find the value of x.
Okay, JC is 19x and JK is 9 times x plus 2 minus 6. What do those two have to add up to? Good, Perla's got it. Why do they have to add up to 180, Perla? Good, because CK is the diameter, so I have a semicircle, and semicircles add up to 180 degrees. So we can basically set these equal to 180. 19x plus 9 times 2x minus 6, not 2x, x plus 2 minus 6 equals 180. Go ahead and solve. Okay, distribute. Now, combine like terms. What do I get? And then what about over here? All right, now what? Now Janelle's good. What's 180 minus 12? And what's 168 divided by 28? We got 6. Good. So see, algebra and geometry. Any questions on this? Any questions on why we made it equal to 180? Okay. Cool. So that brings us to our new topic. We will review on Friday. We'll kind of do a big review on Friday, but for now, we're moving on to this new topic. And go ahead and similar to before, you're going to go ahead and click on the link. And yes, Janelle's, the reason we made it equal to 180 is because that was a semicircle. All right, go ahead and click on the link, and I want you to play around with it for about 2 minutes and then answer the question below. So go ahead, play around. I'll tell you when time is up. And when you get to it, I want you to check the box that says angles C and E and check the box that says angles B and D. Take about 30 more seconds and look at what Perla said in the chat and see if you see that as well. All right, 10 seconds and start coming back to the Zoom. All right, so coming back over to the Zoom, what was that we realized? So Perla kind of said it. Daniel actually said it to me like right away. He noticed it. Opposite angles add up to 180 degrees. So look at D and look at B. In my example over here, 68 and 112. Does that give me 180? Yeah. Now the other two, C and E. So that's 96 and 84. Also 180. And so that is basically the big thing that we're learning today. So it's pretty simple. When you have a quadrilateral that is inscribed in a circle, the opposite angles add up to 180 degrees. Do I have any questions on that so far? No. Okay. So there it is. It's called the inscribed quadrilateral theorem. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. And as a reminder, supplementary means that they add up to 180. So go ahead and tell me in the poll, what is the measurement of angle L? Okay, 4 out of 8 people have answered. Let's get those 5 out of 8 has answered. I'm waiting on 3 more students. Go ahead and put your answer in the poll in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Good. 100% got it right. So very simple, right? They add up to 180. You just got to subtract from 180. So in this case, what did we do? We did angle L, so 180 minus 115. 180 minus 15 gave me my final answer of 65 degrees. Questions on this? Okay. So sometimes it's very easy. So here's another pretty simple example. What would be the value of x and what would be the value of y? Good, x is 100. Y is 109. Very, very simple, right? So in this kind of scenario, if you just got to figure out the missing value, you just subtract from 180. But as you guys know, sometimes they like to kick it up a notch. Can't make it too easy, right? But we're still going to use the same relationship. So, for example, we know that angle P and angle R equals 180. So let's set a little equation up. This would be 5y plus 3 and 15y plus 17 equals 180. Go ahead and take a moment on your own and solve for y.
If someone else can figure out why from y'all, I'll solve it.
Daniel, you gotta find y for yourself.
No.
Yes, sir. Come on. That's not that hard. This is a very easy equation. Very easy equation. Come on. You can start sending me your answers in the chat if you have them. Good. 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Daniel, when I'm solving for y, what should I do first?
You had to isolate y.
So how do I get there? What do I do first?
So first you have to add numbers like I forgot what it's called exactly, but you have to like add the like numbers or something.
Yep, combine like terms. So what do I get?
There. So you get 20y plus 20.
Good.
And then you could subtract 20. Which gets you to 20. And then it's 20y equals 200. And then
Subtract 20.
divide,
Subtract 20.
you subtract, oh, it's 20y equals 160.
There you go.
And then you divide both by 20 to isolate the y. And then you get um
16 divided by 2.
80.
8. Good. There you go. See? I know you can do it. You just get lazy on me
And
sometimes,
then
Daniel.
you just have to plug them into the equations.
Good. So go ahead now. Anybody else can give me these answers. What would be angle P when you plug in 8?
So angle P would be 43.
Mm-hmm.
You could use that angle to figure out what R is, but
Mhm.
you could also just plug it in.
Good. So what do we get for R? Any which way you can figure it out.
Um,
Oh, I see Jalen already put it in. Okay, 137. Good. Q,
okay,
you gotta
Jalen
plug
answered
in.
everything already. You don't have to do it.
Q, you got to plug it in because there's no other way. So we plug it in, we get 64 plus 53, that's 117. And then we find that to get S, subtract from 180, you get 63. Any questions on this one? Questions going once? Going twice? Good. How did we get 63? Would anyone like to explain how we got 63? Somebody asked me in the chat, how do we get 63? Yep, you subtract it from 180. So 180 minus 117 gives us 63. Because Q, remember Q and S have to add up to 180. Or Jalen's way works as well. They all have to together, they all add up to 360. So you could do 360 minus everything else. Both ways will give you the right answer. So again, angle Q and angle S have to equal 180 as well. All right, any other questions on that? All right, cool. All right, do one, yeah, let's just do one more for practice. Let me just figure out which one I want you guys to do because I have a lot on here, but I feel like you don't need to do all of them. Let's do this one. The hardest one. Now, let's do this one because it's a multiple choice, so it's a little bit easier for me to see. Go ahead and try this one. Okay, I have 2 answers in so far. All right, I've got 5 answers in. 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, answer choice B was the winning answer. Let's check it out. So they give us F, they give us G, and they give us H. Which 2 out of the 3 are going to be supplementary? F and H. So F and H are supplementary. So those are the ones I'm going to use. So that means 4x plus 10 plus 3x minus 5 equals 180 degrees. Okay, G is not supplementary to either of those. G would be supplementary with E, but we don't know E, so we can't do anything with that. Now we're just solving. We're just solving for x. So combining like terms, what do I get? What do I get? Good. 7x plus 5 equals 180. Now we take away that 5. I got 7x equals 175. And then we divide by 7. What's 175 divided by 7? 25. B. Questions on this one?
No.
Okay, so remember, you have to only 2 out of the 3 will work, because it's not that all 3 add up to 180, just 2 out of the 3 will add up to 180, and you have to choose the correct ones. Okay, let me see what this one's about. Here's a good one. Can I have a volunteer read this one, please? Anyone?
The images shows 2 possible blueprints for a park. The park plan is one to build a water fountain that is equal. I don't know how to pronounce that. I'm going to skip it.
Equidistant.
Equidistant from each of the corners of the park. Is this possible for either park? Explain or show your reasoning.
Okay. So they wanted to have a water fountain that is equidistant from each of the corners of the park. So let's think about what that actually means, because that means you got to have somewhere in the middle, you got to have a water fountain, and it's going to be the same distance away from all 4 corners. So what that actually means, let's think back to what we were looking at before. If you have a circle, and here's the center, and you have a quadrilateral, I'm going to make it kind of random. Okay, here's my quadrilateral. Oops, my bad. There we go. Okay, there's my quadrilateral. Think about what this actually means. We have the center of the circle, and what is this called? When I have the center of the circle and a line extending to the edge of the circle, what is that line called? That's the radius. Does the radius ever change? No. So this, whatever this distance is, it's going to be the same when it goes to each of the four corners of the quadrilateral. All four of those red lines are completely congruent because all four of those red lines are the radius. So the question is asking which of the following quadrilaterals would fit in a circle. Basically, that's what it's asking. Because if it wants to have a fountain in the center, here's the fountain, it has to be equidistant from all 4 points. Well, that means that wherever these 4 points are located, you got to be able to fit a circle around all 4 of them. So what has to be true about the quadrilateral itself? If it can fit into the circle, what has to be true about it? It has to be an inscribed quadrilateral. And what do we know about inscribed quadrilaterals now? Good. Opposite sides must equal or must be supplementary. So Perla's saying A is a no-go, and why not? Good. So for example, 157 are not supplementary. So Park A doesn't work out. Is Park B an inscribed circle? Yes. Okay, good. So Park B does work out. And if you actually try, let's see if it works. Let's see if we can actually get it to fit inside of a circle. Now, obviously, this is not a good circle, but I'm gonna, that's funny. I meant to make it a circle. Okay, let's see if I can draw an okay circle. There we go. Let's see, does it work? Can we get it to fit? Yes, we can. Take a look at that. So there you go. So it's only going to fit inside of a circle if the opposite sides are supplementary. There's no other way to make it work. Any questions on this one? Okay, so with the remaining time, go ahead and start logging in to Khan Academy. You're going to be working on a new assignment that I'm about to post, as well as your homework assignment if you didn't finish it yet. So if you haven't done your homework, now is a good chance to get it done. but I want you guys to prioritize this assignment because this assignment will be due at midnight tonight if you don't finish it now. So do this one first, and then if you have any extra time, you may work on your old assignment. And I'm about to post it, so just give me one moment. All right, so it's up now. Go ahead and log into Khan Academy and work on it till the end of class. It should be pretty easy. I don't expect this one to take very long. So if when you finish this one, move on to the other one if you haven't done it yet. That was fast. See, I told y'all it would be easy. Nope, no more Khan. I'm still debating if I'm going to assign one more tomorrow or not. Because Khan Academy doesn't have a good assignment for what we're learning tomorrow. So I haven't decided yet. So no, if you're done, you're done. No more homework after this. All right, I see that Emily has finished, Janelle's has finished, Perla has finished, and Jalen has finished. Oh, and Tyrone. I see, I just reloaded. So those of you who are done, like I said, you should be working on your other homework. So I see Tyrone is starting to work on the other homework. But Jalen, go ahead and do so as well. Rios and Daniel, I don't see anything yet from both of you. So let's get going on it. It's a pretty easy assignment. Takes about 5 minutes, so get it done now. That way you don't have to do it later. Okay, Tyrone, perfect. I was gonna say, make sure you get those done as well. All those hundreds are looking good, y'all. Good job. Keep it up.
Miss, I mean, we're your geometry kids. What else did you expect from us? Like, did you expect us to be like your algebra kids? Like, if you thought that, I'm gonna be offended.
Oh,
Like,
she's throwing hands, y'all. She is, you know you're being recorded right now, right?
yeah.
Hey, yo, algebra kids, we want all smoke.
Matter of fact, I should stop this recording before it gets out of hand here.
Okay.